friends and colleagues, if you move through the booth in Amsterdam, either virtually or in person, you may see a whole stable of racing horses called femtosecond lasers. And some of them, like those three in the upper part of the thing, are just used for special purposes. So the femtosecond laser here is for cataract. That one is a femtosecond laser used only for flap making and keratoplasty, and that one is again for cataract only. And then we have three remaining systems: the C8 from Ziemer, the Visomax from Zeiss, and the Artus from Schwind, that can make lenticle creation, intrasomal lenticle uh, formation that can be used for refractive purposes if they are extracted. Now, if you compare them at the first glance, you see the C8 has the lowest energy per pulse, less than 0.1 micron, and the Visumax from Zeiss has the highest. Also, the repetition rate of the C8 is much, much higher compared to that of the Visumax, and substantially higher than of the Atos. And now the question is, does that make a difference? Yes, it does. We know from the old days, femtosecond LASIK times, that there was the so-called light sensitivity syndrome that was induced by the roughness of the cuts of the femtosecond laser flap cuts. Now, if you look now look into detail of a SMILE situation in the interface, you may see a lot with confocal microscopy. You see a lot of roughness compared to the LASIK flap formation done with a femtosecond laser from Ziemer. You see also there's a lot of backscattering shown in the lower part of the presentation, and that backscattering is a sign also for forward scattering, and that has been the explanation of the light sensitivity syndrome. So extrapolating from here, you can see that the smoother the surfaces that you create, the less light sensitivity you will see. And that's what people that have been treated with SMILE, they need up to 3 months to get rid of the glare and to build up full visual acuity. Next thing is the applanation of the surface, and Professor Mechta already made a point on that. We do have a planar applanation in the C8 and some curved in the Visomax and the Atos, whereas where the Visomax curvature radius is 22 millimeters and the curvature radius of the Atos is less than 20. Nevertheless, and does this make a difference? Yes. If you look at this cornea with a curvature radius of 8 millimeter and the curvature of the interface, you may recognize that there is extra tissue if they are applanated, which means if that from here to there, the touching points is wider than that one, we will have to live with the fact that the cornea has to be contracted or fixed, and this is as a response, you get those undulations of the cornea because that line is bigger than that one. So in essence, those undulations can be calculated from the shortening of that scene between the touching points, and that's what we did. And you may have recognized, and this is a normal eye, the other one was a keratoconus eye, fixed at 9 millimeter by a suction ring, and then you create these undulations, and they are very much depending on the curvature of the interface. If it's plain, you get about 80 microns of undulation amplitude, and it comes down the more curved the interface is. Now, if you look at the Visumax or the Atos, that is not much different from having no curvature at all. And a significant effect in getting a smoother surface inside the cornea will be achieved only at curvature radii of 10 millimeters and less. So in essence, if I'm comparing the three systems in the field, there's not much difference whether it's planar or it is slightly curved. Actually, that is just a little bit of a marketing instrument rather than a physiological benefit. Now let's go to the next case. This is a case after SMILE, has been treated here in Switzerland. And that's what we see all the time. It's a clearly descended uh, ablation, or if you call it flattening zone. And the question is, couldn't we have centered that lenticular extraction more properly? And therefore, you need a kind of lateral movement of your femtosecond laser pattern, which is available in the C8. Yes, we do have an automatic centration. Once the eye is sucked on, that lenticle is automatically centered either on the pupil center or on the vertex. That is your decision, and you will have to program that. And it could be easily laterally adjusted if you don't like that centration. This is not possible with the VisuMax right now, and this is also possible with the ATOS. We do have the cyclotorsion control implemented in the ATOS. Nothing like that is in the VisuMax, and the C8 is still working on that, but it will be very soon be able also to do the cyclotorsion control based on the iris image. Now, the last thing I would like to add is something that is, I feel, is very important. If you have your cornea and you create the lenticule, you would like to have two different approaches. And why is that? Remember, if you go into one port, you always have the problem, am I on top of or am I below the lenticule? And for beginners, it's a really difficult decision. For people like Jod, who has done thousands of that, it's not a big deal. But for people who are starting with clear, they may benefit from these different ports, and you may see such a port that we did already 9 years ago. That is the anterior approach to the that ends up over the lenticule, and that approach that ends up below the lenticule. And with your spatula, you can very easily just separate the two planes or the levels, and you do not confuse it. Because if you may not create a very nice dissection manually, some parts of the lenticule will stay in and creating irregular astigmatism. And I'm seeing at least 2 cases like that per year in my practice here in Zurich, with residual lenticular particles in the interface. So that kind of approach, the intelligent approach, makes our life easier and clear, most probably safer, and shortens the learning curve significantly. Now, in summary, you may see that the 3 machines in the field can do a lenticular extraction preparation with the femtosecond laser, but some of them can do it faster and less problematic with smoother surfaces. You can in those cases, you can also center your lenticule after you have sucked in the eye and you're not stuck with the suction process. And the cut patterns that is used is different in all 3 machines, but doesn't play a role. Thank you very much indeed for your attention.